Okay, you want to start it?
Oh yeah. Uh, Let me first share my screen. So hello everyone. Welcome to the FVCOM online course discussion. For this week, we are gonna discuss questions related to the lecture 6. So I have received 5 questions before the class. So I will first show them one by one here, and later Dr. Chen and I will answer them, and we can have a discussion one by one.
Okay.
So uh, the first question is from Minwoo Park. So Minwoo Park, would you please raise your question here?
Okay. Uh, my question is to, dim to improve the reproducibility of the FVCOM model, flag 42 must be activated. The module used depends on the flag 42 setting. The mode file operates when disabled and the mode file special operates when enabled. The mode file module processed result in
Mm-hmm.
the other message arrived due to the network condition, while the multiple special module is designed to process messages according to the processor number
Mm-hmm.
order. Uh, I am curious about the principle of how fixing the operation sequence by processor rank order improves model reproducibility. Thank you.
Mm-hmm. That's
Okay.
question probably. I can answer first part, then because I know how the thing development, then later for technical part, I think Dr. Suchili can answer that. Okay.
Mhm. So next is
Mm-hmm.
Jimmy Seal. So I found the presentation you attached in the discussion board is kind of similar to the one that you sent last week. So I just pasted here, and this is your question. So could you please see more details about that?
Okay. I discussion board. Then I mismatch for question. So,
Yeah.
uh,
Oh, do you want
wait.
to share the screen on your side?
Yeah. I will share my screen.
Yeah.
Okay.
That's good.
So my question is here. So the
Yeah.
the coefficient of the minimum is you determined that 5 centimeter, but I wonder how we can determine to this coefficient.
Mm-hmm.
So I understand that this coefficient uh, make mass conservations percentage. So my question is if this coefficient more slower than the mass
Solo.
conservation error is
Mm-hmm.
more decreased, then why you determine this coefficient just 5 centimeter? That is my question.
Mm-hmm. Yeah, I can answer the question. Also, I think I would suggest you to go to read my paper recently published in 2022. So later we can allow the Dr. Lee to address the paper to you. You can go to read. Okay. I can answer the question later. Okay.
Okay.
Thank you. Next question, Kifan, would you please see more details?
Mm. Yeah.
Oh yeah, I already wrote down what I want to ask today. So in slide 2 in script, they're saying that water velocity are automatically set to 0 in the dry cell, and then the salinity remain unchanged from the previous time step. So
Mm.
I just wonder, for me, the setting the temperature as same with previous time step is reasonable, because if there is no river or groundwater input, I think the salinity should be same.
Mhm.
However, I just wonder how the temperature is treated in the macrotidal environment with large tidal region.
Mhm.
And for example, during the summer, low tide with strong surface heat flux that makes wet nodes would be warm. However, dry nodes keep their original temperature value during that time. So,
Mhm.
however, when the dry nodes became wet during the flood tide, and then their original temperature value will be used again. I don't know how can you think about that? Do you have any other like
Mhm.
special treatment for that? Uh, yeah, that's my question.
Yeah, I can answer the question later, okay? I can tell you all the reason to do that, okay?
Mhm. Next is from Yunji Song.
Okay. I ask not about the lecture. I ask about the FVCOM Visual Wave Registry coupling model that you upload in GitHub. This week I tried to simulate the Svalbard coastal ocean and wave coupling model, and there was some error when I tried to input the river forcing in ocean wave coupling model, and I never saw this kind of error message. So if you know the reason of this error or have some experience to solve it, I want to listen some comment to fix it. Yeah.
Mhm.
That question, is interesting. Later I can answer the question, then Dr. Lee can add, addition technically. Okay.
Yeah. Yeah. So that's all the questions that I received before the meeting. So is there any other question? No?
Now
Okay.
we can start for first one. They can show the first one.
Mhm.
First one, the CPU one, that's a good question. So then because we use the MPI system, MPI system power rounding. So then, if you only had a two CPU, for example, data exchange, always A and B, right? It's no different. That's why you can get you always can repeat your solution easily, okay? Because you only have a two-way to exchange data. But for example, you have a three CPU, that data exchange is randomly selected. Not like for example, you scale like a node A exchange data for node B first, also C change with B change with C, C change with A, but they don't have this order. The order is randomly be selected based on the computer, based on MPI system. It's randomly. It's not they don't have the order. So this way you can see, because when you do like a MPI simulation, so you have to exchange data between the two regions, but then to make the model consistent for each domain, so we do some kind of averaging between the node boundary. That's what Professor Jeff Cover did before. But then the problem, if you have a random selector data exchanges, but they can be this each time because data selected, the average way they did is randomly the way. That's why they can have the small, difference and the beginning model wrong. So then you continue the randomly selected, the CPU. So that's why, you come out, if you run the whole model for example, for 1 month, look like, for example, you look like temperature. So then they probably, first round probably, and the second round, you probably temperature is not exactly the same. Okay, the reason because data changes randomly. Okay, so then the problem, so the question come out, can we fix that? Okay, can we do something to make sure we can keep the same order, the data exchange? We can fix it, just we was force them to have a data exchange order. But then the Jeff Cover developed the coding, that's the petition, so kind of, make this one just active, just make sure, especially request order. This way, the data can be changed as the For example, you run the first time the model, the second time, you force the model to exchange data in same order between the node. Okay, this way you can repeat result. You don't have a difference come out. But then the problem you pay off. In the time, CPU time, you pay off. We run the two case for the benchmark testing. We found if you specify the order of exchange, node exchange, so you can get your computation times 40% longer. Right? Because Fortran program, the MPI, they always can every computer there, they always ultimately to select how the data change because your computer node is electronic. Sometimes this computer, this node finish, another node probably not finished yet, but they have a waiting time. But this waiting time changes for each time. It's not a coding issue, it's the issue for computer. Okay. So then the problem, I think it's when we tested the coding work very well, but after we update the coding, so specify required order testing because we add a lab module. Some people told me the testing they still found it different, but this way I think the coding need to update. But this part of coding because nobody use, only for proof. That's the question. That's why we didn't upgrade that part. Okay. Although because no many people, a lot of people don't really care. So we also compared other model, see how there's only FVCOM had an MPI issue for other model don't have. We compare with structure grid model with wrongs. Okay, wrongs group all did the same experiments like us. So then they find also same problem. Every time you run the model the 2 times, so you don't get exactly same results. Okay, you get some small difference. Sometimes the order can be 10 to minus 2, largest one. So then we found even structured grid model, not unstructured grid model. So that the difference could be larger than our unstructured grid model. So then we talk to the MPI group developer team over there. They said this problem is not a coding issue. That issue is a computer. Come from different computer have different kind of performance. Because sometimes if you every node is finished at the same time, exchange at the same time, but if sometimes late, sometimes happen. So they just the computer always choose who finish first, who they change data first. They want to optimize this computation time. For example, your A and B, C, 3 node. So for example, this time you run the model, A and B node finish the job. C not finished yet. So then you start exchanging data between the A and the B first. But next time you keep it wrong, so then probably C and the A get a faster finish job. So B now, that's why I started exchange data between the A and the C first. So that's the problem you have. So I think if you really want to use the specified order, you have to test the coding. We want to find I couldn't find the older coding, but if you test it, you still get a different result. So we probably can go back and look at the coding, see which part we not update yet. Okay, so that's the problem. It's not any African issue for all the, the model had used the MPI had this problem. Okay, but problem is not because the error come out not significantly. That's why the people really don't care about that. Okay, but question first raised by MIT group. They work in FVCOM, they get a problem, so they run it for like a South China Sea model. Then MIT group did not get the same result. They was asked, oh, the model, why they don't get the same result? They thought this only a FVCOM issue. But later we had compare, we show them. I couldn't find the slides, we show them. So we tested different model, also different group. We didn't test the model like wrong group tested that wrong model. For other model, MIT GCN tested MIT GCN. So they all had this problem. So then the Professor Jeff Cole to look about why they caused the problem. So then he said that because of just randomly data exchange between the node. So then he included subroutine, some choice get a specified activity, just fix the order of node, right? But then, then he found his result can be exactly the same. But the problem is it's very slow. Okay. Do I answer your question?
Oh, Oh, no, I have no question. Thank you.
Okay.
I also want to add something. So
Yeah.
please make sure when you try to run the partition special flag, please make sure you have turned off all the let's say O3, O2, O1, please
Yeah.
keep it as O0. Because sometimes when the Fortran compiler try to optimize your coding, so it will change the loop order to improve the efficiency. So it could also cause the result kind of different. So please, based on the testing result from Dr. Qi, so we found that if you want to use the partition special, please make sure to turn off all the optimization.
Yeah. I think no, I think Professor Lee says exactly no. I think it's very important. Yeah, that's a popular reason some guys do testing use a specified activity still find a different result, right? Because they use like a Fortran compiler, like a option optimization, use three. So then like a compiler happen to change the coding, when it's wrong. So that's why the specified activity, control probably not work anymore, right? But you have to go to zero. That's yeah. Thank you. That's great. Okay.
So
That
let's
might be a great point. I think sometimes the model show a very different result.
Yeah.
That might be caused by that optimization option.
Yeah. So optimization always sometimes they make you run fast, but sometimes they can cause a problem. Right.
Thank you.
Okay.
go to the next one.
Okay, second question is a very interesting question. You ask a question is why, you know the 5 centimeter, so we use that. So you said that regarding the grid size. No, it's not regarding the grid size. It's just you choose the 5 you cannot change it with the grid size. You have to specify the one number for all the grid, no matter how large or how small it is. Okay, so then the determination is really based on like what is the minimum depth you can choose to make a model perform stably, right? Also can kind of can make this smaller. I told you before, like at the beginning, wide drive point environment, I think it's like a finite element model. I couldn't remember the paper that they use a 20 centimeter. If you choose a 20 centimeter, the model always running very stable. Okay, you don't need to worry about that. Okay, 20 centimeter. But then you can look at my paper like a paper Dr. Lee can forward to you. So you can use a 20 centimeter, but you can be stable. But however, so this bottom is too thick, then the bottom boundary layer. Okay, because we are, a FVCOM model, like all other model, we don't able to resolve the bottom boundary layer. No, like not the bottom boundary layer, just the bottom, whisk layer. Okay, most whisk layer is the order of a centimeter, right? That's why I remember many years ago, one graduate student was in Australia. He wrote a PhD thesis, right? He do the Great Lake model, their lake model. So he said all the ocean models wrong. The reason because they had a the bottom boundary condition not correct. He said you look about the whisk boundary layer, you should have shown the boundary condition U and V equal to 0, right? So then he developed a model. He assumed U and V the bottom equal to 0. But then you look about all other models, including FVCOM, ROS, and MSGC, we only specify the bottom stress, right? We specify the bottom stress. The bottom stress in the low layers, the bottom stress, we did not resolve the whisk layer. So we consider whisk layer by the bottom roughness, right? Bottom roughness in the put it there. So we show the bottom roughness, how large the bottom roughness determined by the log layer in the bottom. Right? We assume the log layer, we use the log layer, whisk layer, constant stress layer to determine what is the CD is. The reason because your model resolution, because the risk layer is mostly like a couple of few centimeter. Your model the resolution at least 1 meter or 0.5 meters, something like this, vertically, you're not able to resolve that. That's why instead of put the velocity equal to 0 there, you have to put it like bottom stress. So then the question come out, if you had a wide dry point, right? So then, the four things I want to mention again, when you turn on a wide dry point, water not conserved anymore. Okay, some people say, okay, your model only conservative when you flooding time, but not in the ebb tide. Because for example, you had a ebb tide come back, so you assume the like a second question, okay. So you assume the water was dry. When it's dry, velocity equal to 0. But the true conclusion, you should put the water in the dry point. Water should be advected into your wet point. Right? You should do that. But the problem is, so you either get advection, you get a flux boundary condition equal to 0 at the boundary. So the water was come here. So you know to get the exact calculation of the water get back to wet point. That's why you get some kind of leaking of the water in your model. But then the problem is because of most of the wet dry point issue, you have a domain so huge. That's why if you use wet dry point, you go to idealized case. No small tank, for example, you go to a wide dry point. If you don't have to continue to put the water boundary, it's just like a salt boundary. You can see the water not conservative. Okay, this is empirical solving. Okay, the problem assumption is you get a the losing the water is much smaller than the water will supply. But then 5 meter centimeter there, so we testing a lot of cases. Like if you look at my paper published, I finally published in 2022. So paper show you why we choose 5 centimeter, because we testing, okay, the model stability. So as model stability or sea level, see what kind of, what the depths we can go to keep the model, still keep the sun time step. Because when you choose a very thin layer, you can do that, but your time step can be really reduced significantly. Okay, that's why I was thinking about. I suggest you read my paper. Okay, over there, just Dr. Lee can show you you go to FVCOM website. You get a publication. You can look at 2022. So this why you can look at the paper. You can see the profile about the stability analysis. So you can understand why we choose the 5 centimeter. You can choose 1 centimeter, no problem. But then, if you can choose as small as possible, good. No, it's a message is you don't want to too big. If too big, okay, you probably you probably risk layer your bottom stress not in the body anymore, just in your boundary layer. Okay, that can cause some dynamics different. But then the way you should go to as soon as possible choose as small as possible. For this reason, we testing a lot of coding. So we found that you choose a 5 centimeter was most reasonable. Okay, we use it as a pond model, Princeton Ocean model. We also choose a 5 centimeter. But you look at the previous ponds model, most people choose 10 centimeter because they make the model stable. I don't know what the people use it for wrong, but that's the most people use that. Okay. So you look at part 1, yeah, this paper, you go there, so you can look about all the detail about the stability function. I show the detail how to work. The problem, particularly you're gonna wide dry point. Okay, I show you what the problem is. You see the methodology. I show you how the I see because you can do the 2D, 2D, 3D mode matching. When you do the 3D mode matching, you lose the water. Sometimes you not before your 2D, 3D mode is conservative each more, because you got 2D mode, 3D mode, you can match each other. But when the dry point, you not make this, you're not able to satisfy that condition. Okay, so that's why you look at my paper, I can show you, I describe what problem you have, why you need to choose small? Yeah, that's to go down. Okay, you can go to read the paper. Okay, so you see, yeah, though we do a lot of testing, right? So then you look about, yeah, you see the stability function. You see, depend on the slope, depend on sea level. Okay, you can choose the ratio, the tan delta t, how to change it. You see that's the slope like this. Okay, slope of difference order. You can go to another one about yeah. So we choose the different kind. You can see the different way. You can. I think you better, okay, to check to read paper first. Okay. Okay. I hope I answer your question. Okay. I can spend the whole night for this question, but I just better read the paper first. Okay. Do I
Okay,
answer your
thank
question?
you. I will read your
Yeah.
paper.
Yeah. Okay.
So I will paste the paper link in the chat.
Yeah.
So please reach it if you are interested.
Yeah. Another thing is we also test this method with the really remote sensing data because we get a fly with remote sensing kind of 0.5 meter resolution for the water cover region for the overtime cycle. We test the method for that one to see how good they are. So we found it's really good. Okay. Okay. Yeah. Okay. Then a third question.
Wait a second. Let me go back.
Sorry. Yeah. Yeah, that's one is interesting question. Okay. So how to calculate temperature? Okay, so you give example. You said no, the no velocity equal to automatic zero, no problem. But temperature is the mass. You look at the equation of temperature. Your next temperature equal to previous temperature plus advection plus diffusion time, right? So if you put a temperature zero, that's mean because the temperature always temperature change you have to base on the base temperature you use, right? But not the velocity. Velocity is zero. Velocity most dominated by your converging, diverging, like a current, like sea level. No, like a forcing. If you put a forcing, they was get a motion, right? But the temperature, okay, you can see you have a temperature, initial temperature. So if you put a zero, for example, this time you get a dry. So then you say, okay, temperature equal to zero. So next time you do the temperature calculation, what is there? They use the previous time step temperature. But previous time step temperature, because this region, we assume the region is because after dry, the temperature keep the temperature what time it was dry. Okay, that's not very correctly. Okay, in this white dry point issue, most region you have two sources for temperature. One source come from advection, another source come from heat budget in the surface. Okay, but then the problem come out if you don't have like bottom boundary condition for heat budget for sediment for something. So you put a heat on, you can overheating or overcooling. Was on dry because it's dry being calculated. So that's why we put the temperature, initial temperature there to make sure when you do the temperature calculation, so you assume when the temperature was assumed in the dry region is the previous temperature. This way you don't get a big jump temperature variability, right? Now, for example, so you get a temperature equation, the partial T, partial capital T, partial T equal to advection, diffusion. So then you calculation temperature when it becomes wet, for example. So then it becomes wet. They had to put the temperature in the previous time to put it there, right? So you can do the two way you can do that. The one way you can see, okay, the temperature the previous time equal to the temperature should be into into your wet point. Okay, but this way, so you have to do the wet point, the temperature put in there to calculate it. So then we found, because you put previous temperature, keep it there. So then you find that the temperature, can be more stable. We just look at more the stability, okay? But then, to be honest, we never look at temperature was on the wet, it's kind of wet, dry point. Like, because the region becomes dry, then becomes wet. Then after 1 or 2 time step, if a computer becomes wet, they can be replaced by the vacuum. All the temperature can be over there. Then the heat budget come in, right? But however, when it's dry, you don't want to put a zero there, okay? You just put some temperature, okay? If you only calculate 1 time step, you can see a little bit different, but then you longer the vacuum, that's the problem can be, the difference can be small, then all water be accumulated by dry point, okay? So that's the reason, so that's you will talk about the macro tight environment. Yeah, that's why we need to consider that you had to include like a heat budget what's in the dry point, right? You had to include like a sediment and the water exchanges and the data. If also you had to make sure we do the OR project a long time ago. So you get a sediment over there, even you treat it as dry, but it's not really dry. That's like a wetland, right? So you have to include a sediment module there to calculation the temperature changes in the sediment. Okay, but here at FVCOM only consider what the vacuum affected the temperature, but did not consider like a macro tide environment what's in the wetland. So if you do that, you have to include another module to calculate temperature, inside in the wetland, inside even you don't have water coming, just like you put water there, even if we call it dry. It's not really dry. It's called dynamic dry, not called really dry, because water never dry unless you get a sand structure. If you had a mud, right? You had a mud, you had a silt, okay? But this temperature can keep there. You can change it in the locally, okay? But the process, is different for what are we doing, okay? That's why we didn't consider that yet, okay? So do I answer your question?
Yeah, I got it. Thank you.
Yeah. No, but you need to consider, because when we do an online project, I couldn't remember. We tried to propose to do in the South Korea, near the boundary of the North Korea in the river. So we developed the whole seven module to see the wetland, because we want a calculation how soft the wetland is. All right. So this way we can make sure, how speed of the water becomes soft. Also, if it becomes hot, you lose the heat. So what speed are there? But then you can include the whole module, seven module calculation, consider about the macro tide environment. But FECOM did not consider that. Okay.
Actually,
Yeah.
the temperature in the tidal flat, I
Yeah.
think it has been becoming an issue in this region, because
Well,
that is also very critical for ecological system
that's
for benthic uh, creatures,
yeah.
crabs and shells. So sometimes we don't know clearly, uh, doesn't understand why some part in this region the oyster is all
Yeah.
gone.
Yeah.
And people ask us what is the reason? And some
Yeah.
people ask us because
Yeah.
some people sucking up the underwater
Yeah.
that cause the
Yeah.
aquifer below the tidal flat is
Yeah.
lower, and that makes the tidal flat is more vulnerable for the temperature,
Yeah.
and that's why
Yeah.
that might be the cause for their death.
Yeah.
So
That's,
anyway,
that's
I think
yeah.
that is
Yeah.
another important issue
Yeah,
nowadays.
I fully understand that, but in the Korea, before Inhan University professor, like a Professor Choi, he used FECOM, he do the wetland, he do the measurement. Okay, he calculation temperature was soil or the sediment was in the wetland. So he determined like a heat budget, temperature, heat budget based on the data. So he come out with some kind of empirical formula to determine the the mud and the sediment was in the wetland reaching the temperature. I completely understand this very issue. Like we have the same problem, right? If you particularly temperature changes, but FVCOM and so far right now, we not resolve that. Okay, but now we have developed another method to determine the bottom flux, but this bottom flux is just by the sediment and memory, temperature, but still need to go to measurement about the sediment. That's why you get a microstructure sediment measurement. Okay, I think so. The guy was a Choi did the work. Another person like what is his name? Jung Lee. No, retired person. Jung Lee, my friend Jung Yang. Professor, who remember he? That's he used to work in the Cody. Right? He did some measurement. But then I think Professor Choi's, you look at his paper. He had a paper published JGR, I think it's many years ago, talk about how you determine the, wetland temperature, okay, in the FVCOM. But then he put like a module in the FVCOM, but his module really depends on the polarization. Okay, if you had if I think his module probably apply to your region. Okay, you can put it, in the FECOM. We already put his formulation into FECOM. Okay, most important for his module to determine the sediment temperature. So here the measurement show the temperature. So then you use that to calculate heat budget into the sediment and the water exchanges. Then determine the water temperature at the bottom. Also, meanwhile, they determine the temperature in the sediment. So based on his paper, look like so work very well. But his method not apply for another region because a different region, like sediment temperature could be different, right?
And I remember the Yang Cho's students
Yeah.
has become researchers at
Yeah,
the Korean Polar Research
yeah,
Centers. He's not working at this tidal flat anymore.
yeah.
But the problem is that his method, we need field measurement data for the
Yeah.
sediment.
That's
So
exactly. Yeah, exactly.
yeah, but because we know that tidal flat is so huge, and I wonder if there's any method for using satellite image, using
That's
for
That's a really good question. I told you, we were thinking about doing that, a couple years ago. NASA has been launched like a $70 million project, okay, to determine the, like biogeochemistry flux in the wetland.
Hmm.
But region we choose like Arctic Ocean because like a lot of wetland. So we want a calculation like a wetland temperature. Meantime, we also need to calculate it about like a DOC, some kind of chemical flux. Use satellite data. Okay, then we had to do the experiment, but something happened, because they request not every no, that's a good, very good idea to use satellite data. I know there's a lot of like remote sensing, the Microsoft, like a very fine scale remote sensing people working kind of wetland, so they can. I don't know how accurate the results is, okay, but I do see a lot of work has been done in that region, but I don't know what the temperature. No, the last 2 weeks we get a person apply the job here. So he used to remove sensing data, do some log work. I also asked a question. I said, could you do, wetland temperature? He said, oh, his data is available, but I didn't see he know how to do that. Yeah. But anyway, I think that's a use satellite data to determine that's a really good approach. Right? That's a really good approach because you agree. Like a Professor Choi's data only had 1 point. But that's the reason I told you, a lot of nature people publish the PCO2 flux. PCO2 flux about the estuary contribution of CO2 graph. So they was find that one person go to one estuary to measure 1 point, right? He know about the CO2, how the the wetland, how the PCO2 flux is, 1 point. He times the whole area for global, right? Then he write a Nature paper published. He said, you actually play the major role about the CO2, balance in the global. Okay, because he used data, he times the whole area of the global. So then I had another friend, okay, is also a geochemistry person. I don't want to mention her name, okay. So he graduated from MIT. I know him well. So she just go to same location. Now the person did. Then he make a two-side measure, difference only the 2 meter. Then you can observe results. That means stronger spatial variability in the wetland, because you get a sediment exchanging water, you get a lot of groundwater, a lot of environment. You can CO2 flux could be completely different, right? So that's why you times the whole area for all the regions. That makes sense. So then what happened? So then finally he was in the public meeting. He told people, you get it completely wrong, right? Right? So then when he no, that's a long story. So when a person promoted tenure, he go to committee. He said, the whole person just making the news, not like a science. This person did not get tenure because that's the issue. If part of the Nature paper did got a tenure, but this guy did defense. After defense, he finally got a tenure. Anyway, so another story to talk about this. But I think the topic is very interesting. I really encourage you, if you can use satellite data. Right? No, remember we use satellite data to determine a Changjiang River, erosion, right? Stress. Because all the sediment model are shown in the erosion coefficient, some stress as a constant number. But however, if you go to Changjiang River, you find this erosion is very different for region to region, especially. So then we use the stationary satellite data come from South Korea. Right? South Korea stationary satellite, you can get the image for sediment every 6 hours. So we use data to develop the 1D model to determine what is what the kind of erosion stress in the bottom, right? Because that's very critical for sediment, vertical movement, like suspension, deposition, really related to the erosion stress. So we use the satellite to convert 1D model to determine each region was stress. Then we put in the model wrong. So we found the model really come out a really good match with the observation. Something you can do similar thing, okay? Right? So I would suggest if you go to the one station measure, okay, the heat budget temperature. So then you satellite data, capability is 1D model, develop the 1D model coverage the satellite data. You can develop the region for those kind of heat budget, or the calculation also determine the structure from satellite data.
Yes.
Okay.
That is a kind of a structure that we are also thinking about it. And actually, Junhyung, when he was here, we are thinking about that direction, but now he's in your lab.
Yeah.
So I need someone who is working on that topic. But anyway, thank you
Yeah.
for your great comment. Thank you. Yeah.
Professor Chen, I have a follow-up question about this slide. But I think I might miss it. But one thing I want to make sure is, so can we just ignore the temperature and salinity values, which is stored at that dry nodes? So these values have no effect on similar properties?
That's good question. You cannot do that. If you ignore the temperature that I mentioned before, when the water from the wet to when the water before the seal is dry, right? So you have the water go to flooding there. So then you need the capturing temperature in this node. When the water becomes from the dry to the wet. You have a two-way to do that. One way you assume that's node temperature, if you want to ignore that, so you have to make sure the temperature, you assume the temperature should be equally determined as the wet point. Okay, just equally, right? So that's mean you at the vacuum you don't need the calculation anymore. You just place that. You see what I mean? But then place that one, you will see the whole water will get a constant temperature going the whole region. Right? So the reason because we keep the previous time, because you look about the temperature is not change a lot. If you flooding time, most like a couple hour, right? So then you have the driving time a couple hour. If you keep the temperature there, you do see the temperature different. Right? You do see the temperature different. So then you see the temperature if different location. For example, before, when you go to near the boundary, you can easy to do. But if you flooding a whole larger area, right? So you had a previous temperature, but the temperature before they had different. That difference can be sure in the, when the water becomes wet. But the question that the temperature correct or not, we don't really know. Right? To be honest, because most of our dry pond model is for coast inundation. Right? That's the reason we developed wet dry pond. We know that. That's why we had a 3D model. We had to consider temperature salinity, but you had to be with assumption everything in there is probably not true. Only the water transport probably true. Because we validation water temperature before in my paper show how the water level, how the water flux, compared with observation that's correct, the speed, timing, also maximum sea level. We compare that. But we never compare temperature salinity because we only put a temperature salinity put there just to make the model stable or wrong. Okay? That's why if you really want to compare the temperature salinity on the wet dry pond, you had to change the coding. Like I said, you had to include the physical mechanism about the sediment temperature change on the dry pond. You have to assume the dry pond is had some kind of not like fully like a dry, like a solid, right? You have to assume the wetland, right? That's why they had a temperature, they got a heat budget get in, you still receive the heat budget, right? The heat flux in the acid interaction. You also need to consider about how the dilution, how everything was sediment, inside the sediment. Okay? You see what I mean?
Yeah, I understand.
Okay.
Yeah. Thank you.
Okay, hope I answer your question, okay?
The next one from Yunji Song.
Yeah, I think it's answer the question four things. I think we probably can provide an example for you because we run a model for FVCOM, like a we watch 3 coupling. We do include the river. Okay, we include all river. Okay, right? We include all river come from northeast region. So for something you should hear probably it's caused by some kind of setup issue. Okay, so we probably like Dr. Lee, I can ask her, this question is very simple. We can give you the example we set up, the river. Give example, you can compare your setup with our setup, see what's happened. Okay, but I don't think anything changing for river setup. Okay, but
Yeah.
something you're probably doing, like when you do the coupling, some kind of module, something you did, not parameterization, just some option for analysis, probably not choose correctly, you can cause a problem. I think Dr. Lee can send you one example so you can compare your coding with the offset. Because we run many cases right now. We run a case with a wind farm, okay, with the old river include. We also run a case in the coast inundation, all include all rivers. Okay, that's why we can give you example. You can fix the problem. That should be easy to fix it.
Yeah, I think this error should be easy to fix. So first, I want to mention that for the FVCOM FVSOC VWatch 3, when this coupling work was done, the FVCOM part was not modified at all. So the river input rate part has not changed. So that is why if your FVCOM alone case works smoothly, then it should be works well with the coupling case. So please double check with your river input file. So sometimes it could be due to the uppercase, lowercase, sometimes maybe one underline. I'm not sure. I have already received your river input file. I can check it later after the discussion. And also, Mhm.
One thing I can add, probably we not the coding you probably not update yet, but Dr. Lu Wang has to find a problem when the water well becomes shorter and want to know the point. So then radiation stress can into the trouble because it had an equation show radiation stress has something divided by like a tangent theta something function, they can go to the zero. So that's why, because you have a wave number times the d, the depth can be go to zero. So I worry about the question you come from river, probably come from another. Usually, I think you can ask, Dr. Lee can send you the update coding. We fix the two issue. One is like a reading stress for the very shallow region. Another issue come from the kind of restart file. Restart can be cause a problem. So we should send you the update coding. Oh, Professor Lee, sorry, I destroy you, okay?
Oh, yeah, that's okay. So I have make a note. I will ask Dr. Lu Wang to share the modified coding to you, Yunji. So please check it. And another thing would be, so when you try to prepare the river discharge input file, so if you still got an issue, so maybe you can try the toolbox that we have used to write to prepare the river input file. So let me share my screen. So here, so
No, you ask Yongji a question. Can you run for river case not to the coupling FVCOM only?
Yeah, there is no error when I simulate only FVCOM.
Yeah, something you set up probably not correct.
yeah.
Not for FVCOM, for your coupling. I worry about it because they had a river issue come out about, I think it's radiation stress issue for the shallow region. Lu Wang meet, that's the problem. He already fixed it, That's why I
Mhm.
think you should get an update code to see what happened. Okay.
Yeah, that
Okay,
could
so
be
go
one
ahead.
reason. I will ask Dr. Lu to send the coding.
Also, we need to update the coding on the FVCOM side. That's why the error not come out for other. Okay.
Yeah. So another thing would be sometimes when we try to write the river name into the NetCDF file, so because it is related to the character length, so sometimes we could make some mistakes. So if you want to try, you can try this MATLAB function called the write_river.m. So here we have listed an example to how to write a river input file, just in case that sometimes we will make some mistake. Yeah. But anyway, please pay attention. Please focus. So sorry. Please try the new coding when you receive that.
Yeah.
Okay.
I think if you can run the FVCOM along with the river is stable, I think it's a problem. To the coupling, probably even the error come from river, probably not from river, probably just for coupling with the shallow water issue. River with
Yeah.
the shallow water, the radiation stress could be the problem. So we found because we can show you the mathematical next time how the problem is. But today I don't have the slides here. The Dr. Lu will show the slides. So we can show you what happened. So then he fixed it when the water becomes very shallow. That could be a problem for radiation stress. Okay, so he fixed it. Also, another person we found recently, when you restart the file, use restart, sometimes they order way information not include in the restart file. That's why they can get a way coupling model can jump. Okay, then you don't see the data come out, so you cannot do the restart. So then this big problem already fixed it. So Lu Wang has been testing, running very well. So that's why we can send an update coding. Okay. Okay. Good.
Okay, thank you.
Okay.
Ah,
Almost time.
yeah. This is the last question.
Oh. Okay.
We still have 5 minutes left. So any other question? We still have time for one question.
Yeah, I think we want to use this the time to have a informal discussion. And most important, you listen to the radio. So most time you want to take the advantage. We can exchange it between me and Professor Lee. Lee is know much better than me about the technical part. Okay, I know the serious part. Okay, so that's why we both can be working hard to answer your question. So you can, so you don't necessarily to ask, the question related to your the week, lectures. You can only ask a question related to modeling. Okay.
Yeah.
Right. Okay. Good.
Yeah. No questions? Okay, so
Okay,
if
no
there's
question.
no question, we may end it up here today. So I will post yes, please.
Really, when I click your link,
Mm-hmm.
doesn't clearly show the paper. So in your class the website, if you put that paper, then might be great. I
Oh,
mean,
that's
when
good.
I
Yeah.
click, yeah, okay.
Excellent. So we can put a paper there. Okay.
Okay, yeah.
No, Dr. Lee, no, you can put a two paper. The
Mm-hmm.
first paper to the methodology, second paper to the validation.
Okay.
How the wide drive point validation, we have to remove sensing data to
Mm-hmm.
validate the model. Okay.
Mm-hmm. Yeah.
Right.
So I will put the link under the discussion video record information part. Yeah.
Yeah. I also had a paper published in 2008 about the comparison with unstructured gray model of unstructured gray model for the X-ray for flattening joining. To show you why you need an unstructured gray model, to do the X-ray, because you can see the water exchange physical mechanism completely different for structure unstructured gray model. Okay. Now structured gray model, because you don't resolve the tidal creek, the water had a look like a main river, then a wetland. You look like two box water exchanges. But if you include the unstructured gray model, you go to the river, you go to each tidal creek. So the water go to tidal creek first, then was flooding on the three-dimension structure. Right? Not only for main river, main river can flood on the wetland. Meanwhile, so each tidal creek can flood in the water. That's why you get a structure is very complicated structure than a structure gray model. So then you put a fish larvae, for example, into the model. You want to track the larvae in estuary. You want to see the trajectory completely different,
Mm,
right? So
yes.
something I think also you can put a 2008 paper over there. You can see how comparison structure model. So that's the reason you have to develop an unstructured gray model into the estuary region. Okay.
Mm-hmm.
Yeah. That's paper. Most people cited my paper 2008 one. Okay.
Mm-hmm.
But that's the first paper describe a structure unstructured for a wide dry port. Okay. Good.
Yeah.
No question, we end here.
Yeah. So thank
Okay.
you so much for everyone joining this discussion, and see you next week.
Yeah, thank
Yeah.
you.
Bye.
Bye.
Bye-bye.